Hello everyone, welcome to the live session of the course CVS VLSI design. So this is an opportunity where you can ask any doubt you have about the topic, any topic of this course directly to me. I'll try to answer or try to explain. You can put in chat box or you can just few things like if you have any doubt about any topic, any questions, any assignment, please post in the forum of the course, a discussion forum of the course, and we usually answer all the questions within 24 hours. There are few questions in the assignments was, I would say, ambiguous in the sense there can be multiple answers. So we this course I'm getting useful. This course is being useful for you. Yeah, Nishantas, how are you? I'm fine. I hope you are enjoying the course and doing well. So please put your questions in the chat box. Otherwise, I will not have any idea what's the doubt you have. So Saurabh Biswas has put a question that please suggest few ways to perform critical path analysis of digital VLSI circuit at say transistor level. Are there any tool to find it? Yeah, there are tools, right? So if you think about transistor level design or gate level design, so you have to rely on the EDA tool, electronic design automation tool, right? What it does, just like HLS, which converts C into RTL, then next step is RTL to gate level, and then finally it is from gate level to transistor level layout, right? So these tools all have capability to show you the critical paths. So if you do not have access to the commercial tool, like if you say DC from Synopsys, or say if you targeting FPGA, then say Xilinx ISE or Quartus from Altera. So all this core tool will say you what are the critical path, what is the timing, which path is not meeting your target blocks. All this information they provide, right? So if you do not have access to these tools, so it's because sometimes you do not have the institute may not have access. Many times this tool has a student version, right? Academic versions, which is free. And in top of that, there are few open source tools coming, right? So I'll ask you to take a note. There are tool like XLS, which is an open source HLS tool, which is developed by Google and maintained by Google. So this you can utilize, right? If you do not have say access of Vivado HLS or PTS, then you can download this tool and try to use it, right? So this is also something you can do. And then there are open source tool like OpenRoad. Again, this is maintained by Google. It's similar to the DC, right? Design compiler of Synopsys. So these tools are free. You have to just download and use it. So just in a summary, uh, uh, there are all EDA tools that just report you the critical paths, right? You need to just use any of the EDA tool that will give you all the detailed information about the timing of your design. Okay. Nishant have some problem posting question. I tried doing it from NPTEL module page, but they are not posted. That is a bit surprising. But I have seen so many questions in the discussion forum. It's not that we are not getting questions. Have you ever okay, so regarding register binding. So you have R1, R2, R3 in same dual port register bank. Okay, so R3, yeah, we have answered this question, I guess. R3 equal to R2 into R1. So we need to read R2, R1 from for operation V1 as soon as we calculate R2. We don't need to read the R2, R1. Okay, so okay, so the question, let me try to understand the question. So we can write R3 in the same bank. Yes. Yeah, I understand your question. Effectively, if this R1, R2, R3, if all are in the same basically memory, right? Register bank is gonna do nothing but a memory. So it means you are reading two values, R2, R1, and then you are writing back R3. So these all are kind of happening in the same clock, right? So there are two reads and one write. So if it's a dual port, you have to do it in a two cycle. So if you just have a mapping like this, this R3, R2, and R1 all are belong to the same register bank. Then this you need three basically memory access, two reads and one write in the same clock. So in the sense that you need to basically schedule this in kind of two clocks, right? So yeah, this question was there in the assignment, I remember. So yeah, I mean, I think the answer that we have provided was incorrect. So we'll recheck these questions, right? So we so that we can write R3 in the same year. So here there are three memory access. That is the to answer your question. I hope it is clear to you. And regarding Saurabh has mentioned that you have to join the Google group. Then only you'll be able to post questions. I hope. Yeah, thanks Saurabh for pointing it out. Any other questions you have? Saurabh asked, what are the most recent advances and standard performance metrics in area optimized runtime configure ALU for digital system? Area optimized runtime reconfigurable. So many terminology you have used, right? Recent advances, standard performance metric. So there are two questions, right? What are the most recent advances in area optimized runtime reconfigurable ALU? I don't know what is utility runtime here. Optimized reconfigurable, I understand. But runtime reconfigurable in the sense you try to mean that you can use the ALU for any operations. I'm not very sure. See, one thing just to answer this kind of questions is if you look into the ADF flow, this area optimization, these are all being very well researched area. Okay. But still, based on the size of the, see if you, since you have mentioned the reconfigurable ALU, right? So I'll assume it you are asking the questions for FPGA target. Okay. So now you think about what is the problem. So you have a big combinational circuit, which is say some full adder or say a get level implementation of say a multiplier, right? And so most of the time these multipliers are getting mapped into DSP. So in the FPGA there are DSP block which are the highly optimized implementation of the multiplier. Okay? But if you, I'll suggest you to look into the FPGA architecture. If you go to the DSP architecture, you'll see it's not only a single multiplier. There are pre-adder and post-adder. So effectively what it means, you can do a multiply and accumulate things using a same DSP block, right? So the idea here is that you in your design, you have to suggest a pattern, right? The maximum pattern that can be mapped to a particular DSP block. This is all about multiplier. So it depends on how your tool can identify a bigger pattern is only multiplier or multiply and accumulate plus a pre-adder. All those things is possible. So the point here is that how efficiently your tool is implemented to identify such pattern. It depends on that. Now, if you think about the LUT, what is LUT? It's basically computational unit, right? And if you look into the LUT, let me just probably open the PPT and try to write here. I think my screen is visible. So if you think about a LUT, right? So LUT is what you have a ROM. Okay, yes, I have to share the screen. Just a second. Let me just share the screen. Let me enter screen. I hope my screen is visible. So what I try to mean is that if you see the problem of LUT mapping, so in a LUT, what you have basically a memory, right? A ROM. It can be a single bit. Say suppose it's a 4 input, right? A, B, C, D. 4 input, right? So then there are 16 locations, 0 to 0, 1 to 15. So there are 16 locations. And now you have A, B, C, D, 4 inputs, right? So now these 4 inputs act as the address for this memory, right? And what do you store here? So say suppose A, B, C, D is 0, 0, 0, right? So now what will you store here? What will be the corresponding output when the value of A, B, C, D is 0, 0? I mean A, B, C, D all 0. So let's the output is 1. So you'll store 1 in this location. So suppose say A, B, C, D value is 0, 0, 0, 1. The value output is 0. So you'll store here 0 and so on, right? So what is going to happen is that now this ABCD inputs will act as an address to this ROM. This is the LUT, and the corresponding output will come, right? So now, how do you map your conventional circuit into this, right? So suppose you have a big circuit, right? I'm just taking some arbitrary circuit like this. This is no specific thing. I'm just drawing something to show you. So something like this, and say this is so now you have this circuit, and what is the thing you have to do here? You have to basically you have to just show that let me just clear this a little bit here. So what I'm trying to mean is this, right? So this is your design. Now if you try to map this design into LUT, what will you do? You basically try to identify a block of part of the design or a pattern that has 4 input and 1 output, right? So if you think about this way, this is one of the pattern where you have 4 input, 1, 2, 3, 4 input and 1 output. So what I can do, I can take this particular part of the design and I can identify what will be the output corresponding to the value of 4 inputs, right? All 16 possible values. And those 16 values I'll store here, right? So and then I'll say I'll replace this part with a single LUT, right? This is what is called LUT mapping in FPGA. So effectively what is happening here, you are basically identifying a circuit. It doesn't matter how many gates are there. Here I have identified a circuit of 4 gates. It can be 4,000 gate also. Only requirement you have is basically 4 input, 1 output, right? Whenever you take that part of the circuit and then you try to see what are the 16 possible values, because there are 4 inputs. Those 16 possible values you store here and you access. So now you don't need these gates, right? You just this LUT will be equivalent to this. Now look into this circuit carefully. If I take one more pattern, say the entire circuit, right? So here also you have 4 inputs, 1, 2, 3, 4 and 1 out. So effectively for the entire design also you can identify the input output pattern, right? So if what are the if you give 0, 0, 0, 0 here, what is the output? If you give 0, 0, 0, 1, what is the output, and so on, right? So all for 16 cases you can identify. So then you also can map this bigger one into the single LUT, 4 input LUT. Now the question here is that now how do you identify what is the biggest one, right? So if you start from this node and if you try to do a DFS kind of thing, whenever you get 4 output, 4 input will stop and then say I'll put this into LUT. Then that is suboptimal, right? So what I have seen here, the design I have taken, I can map the entire design itself a single LUT, right? So this is where the tool, how tool work, right? What I'm trying to mean here is that this area optimized things that you talked about is finally how many unit of resource you're using. So this is a very well-known metric that how many LUT are using, how many DSPs are using, and so on, right? But it all depends on how your tool is implemented. So in this design, if somebody give me one LUT, that is the best possible mapping. Probably if you take this one and then you have to take many other cases, right? Because now this can be one more mapping, right? So, and then this can be one more mapping. So there are 3 LUT you might need it here. So what I'm trying to do is that, so for the same design, you can have 1 LUT or 3 LUT. That I'm the way I'm showing here. So the point here is that it depends on how do you implement this. So you try to see how your design get mapped into hardware, specifically for reconfiguring the FPGA. So ultimately it depends on how your tool is implemented. But basic parameter is I will say this the number of resource you are using, right? So that's all. Okay. So I hope it's answered your questions. So these tools are getting advanced and they are coming up with very new way of mapping things. There are a lot of way you can map a design. So I have taken a very small example, right? But you think about there are 1 million gates there. There will be many way you can map it, right? So it depends on how fast your algorithm is to identify the minimum LUT to cover the entire design. So this is kind of pattern matching problem, right? Or say pattern coverage problem, right? So these are all interesting area. If you are a little bit into EDA, you will understand all this problem and what are kind of solutions you have. Okay. So Nishant has one more question. That's sir, I have follow-up questions. If you are sharing resource like register to different, so we need to make sure that many variables will be using same register would not assigning the all register to same register bank be problematic. After all, we have the questions getting dropped, I guess. I did not read the question. So if you have the question, probably Nishant, you can put it here again. The questions being dropped. So the question is got deleted, right? Yeah, I think, see, the basic philosophy here is that when you try to put the register into memory, you should see what is the register access pattern, right? And if all the register that getting access in a particular clock step or in a clock, if you put all of them together, then you need this many access. That will create a problem, right? What you have to do is basically you have to make sure that the register that are being accessed into different clock, you put them into together, right? Then you will, what will happen? You can access the register 1 in timestamp 1, register 2 in the timestamp 2. So if you just go by this philosophy, then this won't create a problem, right? Question has been retraced. So if you just follow this philosophy, that is good enough. That registers or the value that are being accessed in the same clock, they should be put into different register bank because they are access being parallel. And register that are actually accessed into different clock, they can be put into same register bank so that they are actually getting access into different clocks. So even if you put them together, does not create any problem. Okay. Vishal has a question, sir. I am second year electrical student. What is the pathway to work in VLSI? So Vishal, just to emphasize here is that there are 2 directions you can choose, right? One is you can be a design engineer, right? So you should able write Verilog designs directly, you should have very good knowledge of Verilog or say designs. I mean, all this design constant, right? Cross domain, multiple clock, how do you use, how the data can go from one clock to another. Those are all design things, right? Uh, how do you basically develop a design? Okay, so there are demands in the industry, VLSI industry. So one set of people develop IP or intellectual property directly. They write the Verilog code directly, right? The RTL level design directly. Okay? So this can be one career choice in VLSI. The other one is basically you develop the system with, you should know all the synthesis tools, right? The HLS tool that is being done in this course, logic synthesis tool, other physical synthesis tool. There are many other tools. There are some tools that can do the power analysis. There are some tools that can do this testing, test case generations. There are so many. There are simulation tools. So you should, the other domain is that you can actually develop these tools, right? Where I work effectively, right? I develop all the synthesis or the softwares for verification, security, and synthesis, right? So that is another domain. So there are two way, and this what happened. This design engineer, they develop the RTL, so they should have a very strong knowledge about the design, and then they should also have the new knowledge how this tool being used in their flow, right? You don't be able to generate the layout directly, so you have to use the tools. So there are two different tracks. Either you become an EDA engineer who develops software for the hardware industry, like me, and there are people who works directly on the design. They write, they design the code. They basically write the hardware directly, right? And there are also people who works on the analog domain. I don't have much idea about the analog domain, but there are also scope in analog design as well. Okay, I hope it answers your question. Okay, I think if you have any question, please put it here. Otherwise, I'll wait maybe 5 minutes and then we'll wind up the session. Thank you again for your interest in the course, and I am sure this course will be useful for you. Can you just give the full form of LRM? I don't know what is LRM. What is the full form of LRM, Nishant? So I'll request Nishant to give the language reference manual. Okay. Yeah, understood. So see, I think you try to mean the Verilog or VLSI language. There are good books out there, right? So for example, for Verilog, you have Palnitkar book, which is very good book. So you should buy one good copy, I mean, good book, and then you read from there. Online resources are good, but just having a very strong knowledge, sometimes reference books are good because they develop the content very logical way. Okay, I hope that is your questions. Language reference manual, I don't know actually. Uh, I hope this is your questions. And for these tools, there are manual, right? So design manual where they talked about all the optimization the tool have, and these are free, right? When you go install, you will get it free there. So they have talked about all the pros and cons, what are the things can be synthesized, and what will be the consequences of something. Specifically, I have seen Vivado, HLS, or VT's reference manual is quite good. These are the things I don't cover, right? System Verilog or UVM. I understand System Verilog and so I mean I think System Verilog and System there have very reference manual or there is IEEE standard reference manuals is also there, right? So you can just download them. Um, I think if you just Google it for System Verilog, there are reference manual and specifically the IEEE standard are there, right? So one thing you can do, you can put these questions in the our discussion forum. I'll answer. I don't have any ready reference of the books here, but I can just check because this course is not about System Verilog or EVM, right? But I can always give you the good suggestion about what is the good book to for learn these things. On the other hand, when you do this design, you should know how to write properties or say I have to write the assertion like in SVA or PSL, property specification language, or say system Verilog assertions. So that is also another very good aspect for the designers, right? You just not only learn how to design, but you have to make sure that your design is functionally correct. And for checking functionally correct, you have to write enough properties that will check the correctness of your design, right? So it's basically you just think about your specification, right, in English language, and then the design engineer understand that and he writes his corresponding Verilog or PSDL code or system Verilog code, which is the design. So the way he understood. But there may be certain things which is not supported by his implementation. How do you say that his implementation is correct? There is no corner cases or there is nothing that cases where his system doesn't work, right? So usually what we do is basically we write properties, right? The property that from the same specification, the verification engineer write the properties, and they basically write the properties in any system or in a assertion language like PSL or SVA, and then you can check whether this implementation satisfy this in two ways. One is static assertion based verification and one is dynamic assertion based verification. What is static assertion based verification? So what you do is there are tools which will take your design and will create a mathematical model out of it. It's basically it is basic. So for I'll come to your corner cases point. So there are two way I mentioned that static assertion based verification and dynamic assertion based verification. So in the dynamic assertion based verification, it's a kind of simulation, right? So you have your design, you run on say 10,000 test cases, and you check on all cases whether all the assertions are getting satisfied or not, right? So if all the assertions get satisfied in all block, most likely your design is correct, but there can be some corner cases, right? As you answer questions, because it depends on how do you write your test cases. If your test cases are not enough, then what will happen? There may be some cases which is not covered by your test cases, and those bugs won't be identified. So for that, you need to go for static assertion based verification or model checking. What it does, it basically create a mathematical model, which is called most of the time it's a transition system or FSM, which represent the state behavior, state transitions of your design, right? And then you have also written the properties from the specification. Then it checks whether those properties are satisfied in your model or not, right? And it is a formal way, right? So these tools are formal verification tools. So if we say that yes, your design satisfies all the properties, there is 100% guarantee that your implementation is correct with respect to these properties, right? So this is where the static assertion based verification is useful, where you can actually formally guarantee there is no bug in your design. So that's why this formal verification is very important, but always for quick checking, we do this dynamic assertion based verification just to make sure that there is no obvious bug. Okay, so that can be just be excluded by dynamic assertion based verification. Okay. Nishant look very sincere and attending the course sincerely. Vishal Rao, how can I tell you? I'm not from industry, right? You're asking that how to reach companies for interns in VLSI. I'm not from industry. How can I answer this question? I have no idea. There may be, I mean, usually if you, one suggestion I can give you is if you know their HRs or some person from those companies in LinkedIn or any professional network, you can always approach them. That may be one option. But I don't think this VLSI company take a lot of interns, and they may be very selective in finding the interns. What I have seen here, usually I have collaboration with many companies in industrial, in the VLSI companies like Intel, Qualcomm, TI, Siemens. I usually work with them, and what they sometimes they request me for students, intern, and for job offer as well. So usually for internship they look for 6 months internship. They don't like this 3 month internship, specifically the EDA companies, right? And I work because their tool flow is so complicated that in 3 months you're not able to contribute much, right? So that is one of the constant, because if you got into some engineering college, they may not allow you to go for 6 months, right? But usually, just like other software companies, this EDA companies usually prefer intern for 6 months. Okay, but I don't think there is any straightforward way that you write here or write there, you'll get it, something like this. You have to contact right person maybe, and if you have any contacts, that sometimes helps. Okay, if there is no further questions, then we'll probably wind up in 2-3 minutes. I'll wait for a couple of minutes. Yes, that's what I'm trying to mean. Nishant also mentioned, don't forget to connect with HRs. HRs has all the opening in the industry, in the company, right? So they, if you're CV with them, probably they can put into right place. So thank you again to all students who came live. I'll wait for 2-4 further minutes. If there is no questions, I'll wind up this live sessions. Yes, Sandeep Kumar Verma say thank you, sir. Please provide the whole notes. I think these all are there, right? In my course already transcripts are available, PPTs are available. So everything is there. I mean, I know the transcripts we have only prepared from the automatic generator. So I think most of the uh, the video I have, the transcripts are already available in the NPTEL website, and the PPT are also being shared, right? So everything is there. So Nishant, yeah, thank you, Nishant, as well. I found you to be very interested, very much interested in my course. Thank you for your interest. Yeah, I think if you have the transcript, that should be enough. Sandeep, transcript is basically your conversion, and PDF should be also good enough, right? I think there is option for internship with me if you do perform well in this course. That is what being communicated to me from NPTEL, that top 4 performers get an offer to work with me. I'll be happy to give internship in my group. I have a very big research group here. I have so far graduated 4 PhD students, another 5 is working with me in these domains. There are every year I have 4 to 5 MTech students work with me. And then I have BTech student here who BTech with me, and there are interns coming the summer. So I have a very big group. So if you want to explore the area where I work, I'll suggest you to go to my website check the papers that I have written. So if you feel that those are interesting to you, you can, and if you have performed well in this course, I can offer you the internship, right? It depends on your bandwidth. 2 to 3 months is better. Less than that is not useful. Okay. So, Nishant and one more, sir, 7-8 questions were out of study material provided in assignment 7. I'll suggest you try to solve them. If you listen the video, you'll be able to solve them. It's not, sometimes not all questions are given directly from the thing. So uh, in the sense that my video is good enough, right? So if you just read the video, you should be able to answer all the questions. That is my understanding. Because we do set the question based on the PPT and the video lecture that I've done. Specifically for the second part, the 7, 8, those have been in assignment 7, those are where I talked about this optimization, right? How do you utilize the optimization of the HLS tool, or how do you rewrite your C code, or what is the impact of compiler optimization? And there is no standard book here. One good resource can be VT's user manual. You can download the VT's or HLS user manual. I have taken a few examples, few concepts from there, and I developed the material on my own. But there are a few things I have taken from there, right? So you should go through this user manual of HLS tool. HLS, by the way, is a very good HLS tool. It has a lot of features and it is useful, and it has student version. I'll also suggest who are doing things seriously to download HLS tool, because in this online mode, I cannot take a lab or project, right? In my this same course I offer here, I have a project component, right? Where I give certain project using the tools to get an optimized design from a specific design. So that is not possible in the online mode of teaching. So I'll strongly suggest all of you I'll strongly suggest you download some HLS tool, maybe Viva HLS or XLS, any tool, and try to install and try to run certain things and see the things that is being taught in the class are being done by the tool or not, right? So I'm sure you will see a lot of similarity between the topics being covered in the course versus the tool, what tool does. Okay. So that is kind of a must. If you want to become a master of HLS, and then this is a must thing to do. And I will suggest HLS as industry has a lot of interest nowadays in HLS, because it's give you a lot of easy opportunity to generate hardware in quick time, right? It has a lot of advantages. So it's not bad learning HLS seriously. Okay, thank you everyone for your time. So I'll wind up the session here. Thank you for joining here, and please feel free to post your question in our forum, discussion forum, and we'll have one more live session, right, where you can again come back and we discuss live. Thank you.